All right, can we hear me? All right, welcome to OSX External to DA, the OSX or OS10 way, operating an OSX heavy environment. Okay. Feedback here, yeah. So, myself and Alex Rymdeko here are going to talk a little bit about operating an OSX environment. Some things we've came across in future or past engagements, and some requirements for upcoming engagements. So we had to build a tool to do that, and this not necessarily is focused on the tool itself, but the methodologies that are built around the tool and how to operate in the environment itself. So next slide. So contents, we're going to be talking about introductions here real quick, tradecraft preparation, what do we need to do to get ready for the environment, challenges that you may face when operating an OSX environment, the agent that was developed for this. So when we start the actual scenario, we start from phishing and go all the way to getting a DA access through OSX only. We don't touch, well, we touch Windows, but we don't actually laterally move to Windows at all during this engagement. So we'll start at phishing. Once we've implanted, we'll do some host enumeration, privilege escalation, persistence, network and user enumeration. You can see who's on Active Directory and stuff like that, and where we need to go, and then finally lateral movement. So next slide. Introduce yourself.
So as you mentioned earlier, my name is Alex Rymdeko Harvey, and it is a extremely long name, I know. Former Army, got out and went private sector and enjoy this stuff. Dev, open source all the time, and I am a father and have a family. And I also work for the Adaptive Threat Division at Borosh Group, which is based out of Northern Virginia. So if anybody's ever interested, just come hit us up and we'll definitely talk to you guys.
My name is Steve Borosh. I'm also with the Adaptive Threat Division, Borosh Group. Spoke here last year with a previous colleague of mine, Chris Trunzer, on Egress Assess. I don't know if any of you guys saw that one. So it's good to be back. And prior Army infantry combat veteran, and went from kicking in doors to breaking down network systems. So a bit of a career change for me. So what we're going to talk about here is basically as a penetration tester or a red teamer, our engagements these days kind of tend to become a little cookie cutter. You know, we get on one environment, we do the same things, we move on to the next client, and it's repetitive. We had a couple clients recently that were OSX centric. They did have some Windows on the environment, but they specifically wanted us to target their OSX users because they felt they were safe because they were using Macs. So with that, we had a good buddy of ours, Will Schroeder, Harmjoy. You guys might know him on Twitter. He had developed Empire, the PowerShell version. Last year, released it at B-Sides Las Vegas, I believe it was. And we had been wanting to do this for OSX for a while, and finally, a couple months ago, the opportunity arose that we had to op in an environment which needed it. So within 2 weeks, he ported everything from PowerShell Empire over to this with the controllers, and the rest of us added all the modules and everything for it. So what we're talking about here is not just about the agent itself, but we're going to talk about the challenges that we face when operating in the environment, how the tradecraft evolves. So typically, you know, we'll do our typical enumerations on the Windows side, and while most of that plays over into the OSX side as well, some of the things are different. Some commands are built in that you can use on OSX and that aren't available on Windows and vice versa, so we'll talk about that stuff. Adversarial use, briefly cover this. Adversaries today, a lot of people like to think that they're more secure because they're running OSX. But in fact, there are quite a few adversaries out there that use this for malware, that also have, like Hacking Team has a remote command system. remote code system compromised platform, which is basically their closed source version of what we have, I'm assuming, where they can do screenshots, key log, and all that stuff remotely through their own RAT. So people do operate with it. It is something for defenders to look out for. Just because you have one operating system doesn't make you secure. So the scenario, client requests an external penetration test against their corporate infrastructure. We're going to start from phishing. We have a payload right now, which we'll cover here in a minute. Basically a macro, fire off in Excel on OSX and get our callback and go from there. We'll say that about 90% of their users use OSX, with most of their developers and servers and stuff like that being on Windows, which is commonly what we've seen in the past. So the goals for this, we want to phish some users. We want to elevate local privileges, of course. A little different on OSX than it is on Windows, as most of you know. And we want to move laterally if needed. We have different options available to us. And gain control of the Active Directory domain. That doesn't mean physically get on there. We just want to know that we have access as a DA in this scenario. So, tradecraft prep. This is important, knowing your environment, knowing the lay of the land. Anytime we come on an engagement, we want to do our due diligence ahead of time so that we have the right tools, the right people, and everything that we're about, going to do on the assessment is as planned as much as we can, because we can't always plan for certain defenses if you're coming in and you don't know what's on the other side. So gain access, situational awareness, escalate our privileges, and establish persistence is a big one. What we've ran into a lot in the past, especially with OSX, people just close their lids or unconnect from the VPN during the day. So we want to make sure that we've got a good foothold. And then finally, laterally move throughout the network to hit those key targets and show impact to our customers. So, some things to note that we can live off the land of in OSX that we can't do in Windows. We have native PB paste, which is copy your clipboard, screen capture, which we can grab screenshots natively, and we talk about native versus non-native. Native being that it's a built-in command on the host, that we don't need to develop anything for it. What we found that certain systems, customers have defenses in place like Carbon Black, and they'll signature for PB paste or screen capture. If you run those commands, somebody's going to get alerted. So what we try to do is, in Empire, we'll have both options for you if possible. We try to script out some stuff in Python and that mimics what these things can do, and hopefully not get signatured. And the methodology, as I stated before. Next slide, please. All right, challenges. So we got the call to come on our first assessment that had a heavy OSX environment, and kind of wondering what do we do, where do we start, what do we look for. So let me Google this for you. Not much out there on operating in OSX environments. There's no open source asynchronous remote access Trojan other than like Puppy. Puppy is great, but it doesn't have some of the things built into it that we wanted on our engagements. So we decided to port Empire over, PowerShell Empire, into a Python-based version. Need to think about lateral spread. In OSX and Linux, we're missing things like WMI. We don't have PSExec. We don't have a lot of those tools. We can't remote desktop as easily. Basically, we're reduced to exploiting remote vulnerabilities or SSH into another host, which we'll talk a bit about later too. And less phishing payloads. When you need to get that first vector into the network, it's hard sometimes with OSX because we don't have Word documents with OLE in them. We have less executable types of payloads that we can send for people to click on and download and run, things of that nature when you're talking about phishing. So we have right now macro and an Apple script that we'll talk about. and I'll hand this over to Alex.
So now we're just going to cover some of the basics of the agent. Obviously, the talk is not centric around the agent, but it's obviously a crucial piece to success for the operation. So this is obviously just the main CLI setup that we have. It's really familiar to Empire if you guys have used it for any of your operations before. So as we talked about before, standard RAT, pure Python, written for 2.7, and it was developed by Will Schroeder. As we talked about before, his handle is Harmjoy. You probably heard about him before, potentially. He does a lot of stuff in the Active Directory side, and he was a really big on to developing Empire beforehand. It's asynchronous C2, so it's kind of like most standard agents out there currently. In our case, we operate heavily with Cobalt Strike, so it's a familiar platform for us, and it's pretty easy to move over to. Obviously, being as a client, we had to make sure that the information was obviously secured. So it performs a secure Diffie-Hellman exchange process, and then is using AES after that, of course. So initial access there is some basic phishing payloads, things of that sort. That's going to have to be left up to obviously the operator's choice. So a lot of the modules that are actually currently built in are for post-exploitation. And actually being native 2.7, it's kind of easy to move over to Linux if you do have that environment, which is kind of cool, and we'll start moving to building some more modules for that in the future. Something we should note is obviously on the OSX side, if you do have developers maybe you're targeting, we found that little snitch can be quite a pain. It doesn't look too good when Python's calling out. So we obviously added that launcher detection in there for your stager.
And with that, you can turn it on or off depending on your client. If they know that you're coming and they don't mind that little snitches alerting, you can disable that flag for the agent when it launches.
Yeah, so we just want to give some shout outs. Obviously, being pure Python 2.7, there wasn't going to be your standard library imports, so that was a major challenge for us. So anything that we wanted to do outside of the normal realm, outside of Python for library-wise, we had to build either natively, build pure in Python, or just port it over and then adapt the code basically to run in the situation that we needed it for the modules or the agent itself. So we just want to give some shout outs for either the Diffie-Hellman and the AES exchange process to these two guys and the projects that they have out there. So we're first going to start with phishing. So for previous tradecraft, on the Windows side, you have quite a slew of different techniques that are out there with different types of technologies between browsers, Microsoft Office, all these different endpoint attack surface is pretty easy to develop for. So you have everything from browser exploits, OLE documents, which are one of our favorites, or even macro payloads. And not as much anymore, but Java payloads were quite a thing maybe about a year or two ago. So knowing this in mind, we had to come up with some different ways to adapt and overcome on the OSX side. So we have a few different modules currently built. We have an HTML AppleScript module that Steve actually built for us. And that can be used, but in our case, we knew that our target environment was most likely going to be supporting Office. So we went after developing a solid macro in Excel, and we knew that might be the most effective way of getting in. Some things to note is it does support the 2011 Office, but recently we found out that the 2016 updated version of Microsoft Office actually supports sandboxing for, it looks like, for SIP. So that's kind of a concern. But in our case, it didn't affect us. In a Windows environment, quite often you have outdated software, outdated operating systems. They're generally 3 to 2 versions of Windows behind, just because that's how enterprises operate. So while there's Windows 10 now, the most common operating system I see right now is Windows 7. So in the Mac, it's the same exact way. So even though that there's protections in place for El Capitan, previous OSX operating systems are still being used. So that's something to note, and the same way that happens with Word documents as well. So this is just kind of an example of us generating a quick payload. it's pretty simple. It looks exactly the same as you would do in a Windows macro. You basically create the sub and you append the data right into your macro, and you just create a handle or function to that sub, and you're up and running. It's really simple. It's almost feel like you're operating for a Windows environment, to be honest. So once you're on the box, what do we do? What do we need to go after? What do we have at our hands or fingertips? Obviously, these are things that we have to think about quite often, because it's more about end state goals when it comes to red team operations or pen testing operations. So some of the things that we did previously on the Windows side that we use heavily to potentially either gather data about the host or try to privilege escalate. Another tool written by Will is called PowerUp. It's something we use quite often, and it really allows us to enumerate the system for potential misconfigurations or things of that sort, like service permissions, DLL hijacking, things of that nature. Whereas there is some WMI commands you can do for some basic, host enumeration, things of that sort, and those come really effective in the early stages of getting initial access. On the Cobalt Strike side, like I talked about before, that's our main operating platform. For us, there's quite a bit of modules in there that he's been starting to integrate that are native inside of Cobalt Strike, like the net commands, all these kind of things. All these kind of things really help us out. And of course, there's the Metasploit modules, which are extremely, they've been developed for years now, so there's tons of stuff out there for local privilege escalation. But in our case, as you'll notice as we go through this, throwing an exploit is just something I haven't even done in about a year, to be honest, on a local host. Not saying that, it's just the environment today, there's so many other ways of privilege escalation that it's really rare that I even have to even stoop to that level to even throw an exploit on a endpoint. So that's something we should know, and as we move forward, it's going to be the same way in the OSX environment. And of course, knowing your land, how am I going to priv-esc? What can I do? What is a user going to do? How can I use it against them? So some of the things that we found that were really important on the Windows side all translate right over onto the OSX side. We need to be able to keylog. We need to be able to see what they're doing. We need to be able to access their keychain. So on the Windows side, while they don't have a built-in, per se keychain environment, they do have things like LastPass, different types of cloud storage platforms that they do for key storing and all that sort. So keylogging becomes intricate into developing techniques to try to go after those different types of platforms. Clipboard monitoring is another thing. It's actually something we don't do often personally on the Windows side, but on the OSX side, it's going to be really crucial as we move forward, because I'll show you why. Scraping messages. So the nice thing about your friendly OSX environment is everything's integrated. Everything is in one synchronous state. So every time you sync your message with your phone, it's syncing on your Mac if you are attached to that iCloud environment. And that becomes really helpful for things like passwords or searching down maybe potential information of who's actually on that box. Hash dumps, and we'll cover that a little bit more detail, and of course browser dumps to kind of see what your user's up to. So this is something that's a little bit different than the Windows side. Whereas on the Windows side, when you're in user context, keylogging is possible. But on the OSX side, this is kind of a limitation that we had to come across, was the fact that we couldn't keylog. And until you're in an elevated context. So where it doesn't become like your potential priv-esc, it can still be used for situational awareness or potentially targeting applications like to your end state, like SSH or things like whatever the developer's doing on the endpoint. But it still is an extremely vital part of our tradecraft, even on the Windows side and OSX side. We talked about this a little bit earlier. Steve touched this. There is the PV paste native commands that are in play, but this actually on our first Mac or OSX engagement actually got us caught just because it was signatured by Carbon Black. So environments that are more mature and potentially have host-based, IPSs like this, they're going to be signaturing for certain things. Now, this is kind of curious to me, just because the fact that, in most environments, you're not going to catch basically keylogging taking place, but we don't have that type of methodology built into Windows currently. Like there is no like native clipboard monitoring. There is no native screenshot. That's something that you see heavily on like the Nix side. So it's kind of cool, but at the same time, while these things are like at your fingertips, you should be extremely careful about what you're doing on the endpoint because you could potentially be tripping something off. So we actually develop a non-native method, all pure Python, and it basically sets out a clipboard right to a file and it downloads it for you. As we talked about before, keychain dump. So there's been some really cool research done by a lot of people in the industry. In our case, we use the keychain dump. It's actually inspired and adapted. There's a link if you want to go check it out. But the thing that was important for us is that, of course, you have to be in an elevated context to do this, but we wanted to be able to do post-exploitation methods, of course. And your keychain does track a lot of the different sites that you're either storing passwords for, or people even use it natively to store SSH creds and all that kind of stuff. So it became pretty intricate in our tradecraft as well. One thing to note about this is currently with the newest OSX El Capitan SIP enforcements, you're limited to OSX's environments before OSX El Capitan, which is kind of a limitation, but at the same time, I mentioned earlier that in our case, this wasn't affecting us, just due to the fact that the environment that we were operating in was one operating system behind. So it didn't actually affect us on our current operation, but it may be a limitation for future operations for us as we move forward.
I do want to note that there is a keychain dump available that's I can't remember who it's for on GitHub, but you can download the keychain and crack it offline. Probably something we'll add in, port over here in the near future.
Yeah, and that's actually pretty simple. You basically just feed it the user's password that they're using, and you can basically decrypt the whole entire keychain just offline. Another thing that I actually put this one together, but I wanted to have the ability to search your message store. It turns out that it's basically, this is all from user context as well. It's basically a SQLite database that is stored on disk, and it nicely sorts it all out for you depending on the service that you actually use. So in this case, if you haven't noticed, like you can integrate different types of services integrated into the iMessage platform from Google Talk, Yahoo, AIM, and the iMessage service itself. But the cool part is you can search everything from the requesting number, the account where it was coming from, the account where it was going to, and also even the phone number per se. So it's actually quite a treasure trove of information from a collection standpoint. But in this case, I built out some basic functionality so that you can search by the account that you're targeting. So as you can see, there's actually email accounts that are attached to each individual iCloud user. And then we also had the ability to search in the message text. So in this case, if you were looking for, I think the bottom examples, did you change my password or something of the sort, and you can kind of hunt it down. These things get massive. In this case, I think I'm up to, this was on my box, and there's over close to 6,000 messages. So dumping that all to the agent would be kind of crazy. So you have to be able to sort through it and kind of play around a little bit to see what information that you can gather from it. Same way in the Windows side, the hash dump command. I mean, in Beacon, there's other smart hash dump stuff. Like, there's tons of research on this, obviously, on the Windows side. But on the OSX side, it turns out that while gathering user credentials is great, but on the Windows side, generally we have a local administrator account. And more, I would say more mature organizations will have some way of administrating that, either by some type of password changing binary or homegrown or potentially lapse, which is the current Windows methodology where they're trying to push on people and move forward to. Obviously, the same vulnerabilities don't apply for passing the hash of these things, but from a architectural standpoint, administrators are going to administrate. So they're going to have some way to talk to that box and be able to control that box from a remote endpoint. So although it's just a standard hash, if we can be able to access the hash store, grab the administrator's hash and crack it, in this case we actually output to a hashcat ready format, we're able to basically gain access to a strong subset of the Macs or OSX and OSX boxes that are being domain joined. And that gives us a huge leverage point potentially if your environment is at that point and mature enough to have, the remote administrating aspect of the OSX side. Obviously, this is all dependent on the client. So while hash dump may be useful for us, it may not be useful for like a smaller company or something of the sort. Finally, browser dumps. These are basic, interpreter modules. Tons of stuff out there on this. It's the same thing. I think it's a standard SQLite database. Yep, standard SQLite database. Right now we support dumping Chrome and Safari, and you basically can specify the output. Like I stated before, for end-state operations, for things on the red team side, knowing what your user's up to, what they can touch is really important to us. Because in many cases, while getting access to the initial host is great and all, it's usually some type of hardened system on the back end that we're trying to target, and we need to find the right user and the right box to get to it. So this kind of stuff can be really helpful for giving us an idea of what that user's up to. So now we're kind of, potentially, let's say, we've gathered a whole bunch of information. We got an idea of what our user does. We have an idea of potentially some passwords that we've gathered either through clipboard monitoring, maybe something from iMessage or from email enumeration. And we can move forward with that and potentially try to pseudo-spawn. So obviously getting into a root context is no different than doing, let's say, make token, creating a token on the Windows side, injecting into a process, and then gaining a system-level context on the Windows side. The same kind of thing has to happen on the OSX side. So while injection's not currently supported, I think it's something that we're looking heavily into, and I know SIP has a lot of protections against it. And one major factor is that you have to be in a root context. So that's not possible right now for us, at least. Just for right now. Obviously, there could be more research that comes out and stuff that we can utilize. But right now, we use pseudo-spawn. And that basically will keep our old agent, but then also spawn a secondary agent with the root context.
If you're familiar with PowerShell Empire, you can see there at the bottom, if you can see down that far, that once the second agent comes back, it annotates whether that's in an elevated context or not by putting a little asterisk next to it, so you know which one of your agents are elevated and which ones aren't.
So as we talked about before, persistence is something that's kind of key for us on the OSX side. Whereas on the Windows side, Tradecraft, it's pretty rare that we have to drop persistence, at least to disk, just because of the fact that you can find places to survive like servers or high uptime areas in the network. So whereas on the OSX side, you're potentially dealing with a lot of laptops and things of the sort, which are really, really bad to persist on. Like I would never do that in a Windows environment. But on our side, that has to be something we have to keep into account. Developers standing up, closing the laptop, going to the next meeting, and popping back up. So we had to take that into account. So we had to develop some methods for basically implanting on the box. Some of the stuff that we do on the Windows side, you guys all know about the registered run keys, startup folders, maybe a WIMI event filters, tons of research out there on that currently, DLL hijacks, or basically just net user add and potentially coming back to the box later. On the Linux side, we have some stuff like cron tab and add user, stuff of the sort that we've all kind of seen over the years of progression. But on the OSX side, we have some unique ones that we kind of developed, and we put a lot of time into this. So we're going to cover login hooks, something unique to OSX, cron tabs, launch daemons, and of course dial-up hijacking. So while OSX is a Linux or a Nix-based platform BSD, they do have some of their own interesting methods of handling developers' needs. One of them, previous to El Capitan, was these things called login hooks. There's tons of research on OSX persistence. I think it's by Synac and a couple other companies out there that have done presentations. So we kind of use some of this material to develop some of our own methods. In this case, I wanted two different ways. We had to have the ability to either have user context persistence, and we had to have the ability to have system level context or root user context for our agents. We wanted to have both. So in this case, login hooks provided our user level access. This does need a elevated context to install, but the cool part about this is it's extremely simple to install. Basically use the max defaults tool, and you basically can set this thing called a login window hook. Some of the things that you have to be kind of careful about this is it's in line with loading. So as your system loads up, it goes through obviously all the system, kernel initialization, all the way up to the login prompt. Once you log in, it will execute either the launch daemons, and then it will go to login hooks. The interesting thing about login hooks is that they're in line. So if you fail or something goes wrong where for some reason the script hangs, you will hang the user as well. So it's something to keep in mind. So it could be potentially a dangerous method, and it's why it's technically deprecated in the OSX El Capitan and below. I think it's been at least 2 versions back. I think it is actually technically deprecated, but it still works. So we're going to use it. And I'm going to pass it back over to Steve to talk about some more persistent methods.
All right, so as many of you Nix people are aware, we've had crontab around for a long time. It's an easy one to install. Unfortunately, at this point, it does require we drop something to disk. So as you can see here in the example, we set the module to run at 0800 hours, and the module will kick off and run our file name run.sh. So every day at 8, it'll kick that persistence off for us. And you can change the hours, or if you just want it to be hourly period in the module. And it's a really good one to have on hand. We actually use that on the OSX, one of the last OSX engagements we was on, and I used this module. Also works on Linux, of course. And you'll see in the structure of the RAT that our modules are placed in directories, whether they work on OSX pure or Linux only, or both. They'll be in multi-folders. So you can kind of target either operating system with this one. So thanks. Launch daemons do require sudo, do spawn on reboot, and Zorier, one guy that wrote this one, actually wrote it in, so as soon as the agent dies, it'll spawn another one, so you're really hooked in. And you can see down here in the bottom, in the red text, it says, module is not OSX safe, do you want to run? And we have those, if anything is dropped to disk, it'll kind of warn you, so that forensically, if you need to clean up afterwards, it'll let you know. Did you have anything you wanted to add?
Yeah, I actually wanted to add a few things on the launch daemon side. It's currently its max approved way of setting up services. So it's kind of interesting. I mean, we dug pretty deep into this one recently for some of the future blog posts that we're going to be putting out for actually operating with the agent. And something I covered pretty deep on this was that how the launchd service actually works. So after the boot OSX process takes place, kernel initialized, you move into the launch daemon side. Launch daemon then takes in a list of, basically searches 2 known directories for a list of plist files, which are like structured XML, with different types of services to start with a whole bunch of different like attributes. So in this case, where his starts automatically, you basically can specify a key to run all the time. So if you have that key specified, that's why that agent will keep coming back no matter what, because it's almost like, well, why did it stop? Okay, great, I'm going to restart it for you. So that's kind of an interesting location to persist. While it can be more dangerous to persist in this location, it also has the ability for the user to add, or let's say for you to target more specific platforms and things of that sort. Because launch daemon also operates on the system context, it also operates in user land. So user context, not user land, because it's obviously all user land. But when you move from the login window and you actually start the initialization of logging in, your launch daemon then goes and researches the path again for specific user-based services that may be started up for that user. So you can either persist, you basically can persist in 2 different locations. If you want to only come on the box when the user logs in, great. But if you also want to come on the box the second this LaunchD starts up, you're good to go. Something unique about this as well is that, like the login hooks, where you're streamlined to basically staying in line with the login, this will launch whenever it has the resources available. So it's a safer way as well.
All right, this one's a really cool one that our counterpart Zorier on Twitter, he goes by, ported over Patrick Wardle's research for dial-up hijacking. So those of you who are familiar with DLL hijacking in Windows, this is similar, a little bit different for OSX. And there's 2 parts to this. You can either search for DLL or dial-up locations manually, but Patrick Wardle built a hijack scanner module that will actually scan your OSX system and see if there's anything that has been hijacked or could be hijacked. So if you're operating from OSX in a defensive position, I would check out his research. He has some really cool stuff out there that looks for malware on OSX boxes, looks for persistence and the common persistence locations that we have mentioned before. So this hijack scanner module will actually scan recursively the whole drive or whatever path you provide it to, and it'll list out any locations that are vulnerable to several things, multiple RPaths, hijackable dial-up locations. Basically what we're telling the system is we're going to hijack when you start up a certain process or application and it loads basically a Mac version of a DLL, we can inject ours in place of that before the application starts fully so that we can take control and have our launcher come back for us in that context. So it'll be the context of the user, and I think the next one. Yeah. So this actually shows by default Xcode is dial-up hijackable. So this is an example of hijacking Xcode on I think it's El Capitan. So what we did, we found the location with the hijack scanner where the dial-up can be hijacked, and we have a module that we can build dial-up to place in the folder. Once you place it in the folder, and the hijack scanner module actually gives you complete directions on every step to take to create the launcher, where to put it on the target machine, and then once the user runs that application, you'll get a callback in the context of that user. Well, this is great and it's cool and it's a place to hide that most places don't look for. If the application closes, you're gone with it as well. So this could be for a persistence. If you want to watch somebody that's running specific software, maybe they've got some custom OSX software on, and you want to know when that developer is running that software, you can kick that off, and you'll get your persistence back that way. But I would recommend staying persistent, another method, as you can lose that once the application closes through dial-up hijacking.
Something that should be noted here that I think Zoria was kind of mentioning is that with the dial-up hijacking is that it doesn't return if the imports are not, let's say like for Xcode, if you don't have the proper imports in the dial-up that's generated by Empire, it will currently crash because I don't think it can actually return back to the original location for the imports. So that's something that maybe like some community help could be, contributed to make that work. And it's already a complicated process. So there are some limitations here currently, and there might need some custom rolled stuff as well. Just should be noted.
Sure. All right, next we're going to move on to situational awareness. So we've established our persistence, and now we want to check out what's going on the network. Previous tradecraft in Windows, we have, you can do ARP scans, see what's around you. You can Nmap through proxy chains. You could run net commands directly from Windows. You can run tools like Eyewitness. Chris Trunzer, a good friend of mine, wrote that. And it'll basically scan for web applications on the network and take screenshots. We could run Harmjoy's Power View, which will enumerate Active Directory, billion ways to hell, because he's been working on that one for a couple of years now. And so what we wanted to do is take some of this tradecraft that's not available directly on OSX. Yes, I know you can install the net libraries on OSX and run net commands, but by default, when we're working from a penetration testing or red teaming standpoint, we want to assume that the target is clean as possible. Maybe they just imaged it. They don't have all these tools installed, and we're not going to install and increase the attack service on the client's computers. So we want to operate from as clean of a machine as we can without actually adding any more to it than needed. So a couple of the things that we were able to port over to Empire, group policy preferences. Many people have ran into this in penetration testing engagements, and treasure trove of passwords usually, because on the domain controller, local admin passwords used to be stored there a lot, and you can decrypt them on the fly because Microsoft gave you the AES encryption key right on their website. So they're not so secure, and that's a big one that's got us to DA in a lot of engagements, so we decided to include that on the OSX side. Active Directory queries, we basically ported the PowerView script over, as much of it as we could. And great thing about OSX is natively it handles LDAP search. So you can perform LDAP queries against the domain controller and do the same functions. You just need to be able to authenticate, which we'll cover. Port scanning, of course we need a port scanning module, see what's out there on the network, hopefully find some web hosts, do some web discovery, and typically we call it looking for low-hanging fruit, and that's one of the modules we'll talk about. I think there might be a couple more now, but currently this is where we stand with situational awareness for Active Directory modules. So we can start off, we can query Active Directory and tell it to give us a list of all the computers on the network. Tell us to give us a list of all the domain controllers on the network or file servers. So we can kind of work our way through the network and pick targets that we'd want to move to, maybe if we want to switch over to the Windows side at some point. And like Alex said, a lot of times we like to live on high uptime servers. You don't find too many of those that are running OSX. So we could target some of those servers. Get group members, so if we want to see who's in the domain administrators group and start to target those users, do some user hunting, that's where we can start there. And other information, user information, that you can pull each user's entire Active Directory listing down as well. And all this is using native built-in LDAP search through your RAT. So once you've got a head on the system, you can run LDAP search as long as you have the ability to authenticate to the domain controller. Group policy preferences, what we've talked about earlier with the encrypted password, you'll see what we're doing in this context is actually authenticating to the domain controller and searching, doing basically like a grep through the sysvol folder, and we're pulling out all of these C passwords. So C passwords, you can see it is encrypted there. It is AES encrypted, but we know the key because Microsoft gave that to us, so we can use a tool like GPP Decrypt. Haven't built it in yet. Probably will build in the decryption on the fly here as soon as we get some more time. But you'll see it'll tell you that it's finished. It mounts the sysvol, searches through it, grabs out all the passwords for you, and then it'll unmount it and tell you it's finished. All pretty quick. And this could be... you see it's old MS 14025, but it's still pretty prevalent on a lot of engagements that we see today. So keep this one in mind. So once we are on the network and we're able to search, in order to use the LDAP search module, you do need to know where the domain controller is. So this is just an example of doing a simple shell NS lookup to find the domain controller. You know it's on the domain called hackme.com. So it does a LDAP query or NS lookup query through DNS and tells you where the domain controller is. And we'll use that information to connect to it in the future. LDAP queries, here's the information I was talking about. When you pull up any of the modules, it'll give you some options. You have bind DN, which would be whatever domain user you want to authenticate to the domain as. So it would be user@hackme.com or something like that. The password for that user, which we probably garnered from situational awareness on the host, clipboard monitoring, key logging, stuff like that, keychain dump. The LDAP address, that would be the address to the LDAP server or the domain controller. You would point that at your domain controller. And then the agent. The agent is whichever agent you want to run this module on. And you can switch that on the fly, or you can set it to run on all the agents if you want. So here we're going to set the password, the username, the bind DN, and execute. And down here you get your list of hosts on the network. We're doing a get computers. So we can see we've got the HackMe domain controller, we've got administrators box, OSX2, Windows 7. So it would be the host names of the machines that we're looking at through LDAP queries. Thanks. This one I built kind of like basically a find the low-hanging fruit module. There's also this in the other empire, the PowerShell empire. So if you're short on time, you don't have time to fully nmap the target systems, and you're wanting to just look for low-hanging fruit, you can give it the port you want to search for. So common port for like JBoss or Tomcat, port 8080. The target you want to scan. So you can give it an IP address or a CIDR address, and it'll actually scan the whole block. And you see the return results. This doesn't tell you that it's exploitable, but it will tell you that they're returned 200. So a web hit 200. Now we know we've got JMX console, JBoss, and we can probably take advantage of that. Next. All right, running low on time, so we're going to get through these real quick and then go through a demo, hopefully within the allotted time here. So we've got lateral movement, previous tradecraft. We had Linux, you can SSH, you can Telnet, you can remote exploitation. We can do Windows. We've got even more. We can PSExec, WMI. We can remote desktop. But on OSX, we're limited down to just a couple things that we've built into the module so far. So next slide. Lateral movement. So this is actually showing pivoting from one empire to the other using the YSO serial exploit that came out this year for Java deserialization. So hopefully within the next few months, we're actually going to combine code bases for both empires, and you'll be able to control your OSX and your PowerShell empires from one controller. We actually have the ability to right now through the REST API that's on both of them, but we haven't quite released that yet. So we're gonna get that going here pretty soon. And finally, lateral movement through Linux or OSX. We can launch SSH commands, and it'll return the commands to us. So if you want a cat etc password or whatever, it'll actually run that command remotely and then bring you back the data. Or if you want to launch another agent remotely, you can do so with the SSH launcher. All right, we're going to skip the gods versus humans and see if we can't show you the demo here real quick. Hopefully we can see this.
Yeah, so we're running a little short on time, so we're not gonna pause this. We're just gonna rock right through it. So right now we're kind of demonstrating like the ability to basically build the OSX macro that we talked about before. And we're first gonna set up, I think in this case, it's already like set up just because we ran the agent. And right when you execute it, you're basically gonna get the callback. That's kind of the interface. You can list the agents that you have on your target space. It's pretty simple. It's like any other platform. You basically use module. In this case, we talked about the clipboard monitoring. So we're actually going to execute getting clipboard. We're kind of like running through this as like a scenario. In this case, we actually got JFrank's password. So that's you're kind of getting an idea of how this actually all meshes together. So once we have, let's say, a potential password, we're actually going to start going for a privilege escalation like we talked about with pseudospawn. So we're basically going to go into the privilege desk side, start up pseudospawn. We're going to set the required options. In this case, you're just going to have to set the user and the password. We're going to let that get in there.
One thing to note on the pseudospawn, I've had a lot of questions before, and I don't have SSH turned on by default, and I don't have sudo rights. But typically, like Alex said before, admin's got an admin. So most in corporate environments, especially with developers on them, you're going to have SSH turned on and sudo rights to those boxes as well.
Yeah, so once we have an elevated context, we're actually going to go ahead and interact with that agent. You're basically going to pop up into that agent menu. At this point, as we talked about before, some of the first things you do is gather credentials on the Windows side, either using Mimikatz or hash dump. So the same thing we're going to do on the OSX side. We're actually going to go ahead and use the hash dump module, and we're going to gather our credentials. Pretty simple. Got the administrator's password. As we talked about before, administrators are going to administrate, so they're going to reuse this password in our demo. We're going to quickly just show the cracking of this process. This is kind of some of the process that we went through as well before. Yeah, we're just going to skip through this because we're actually limited on time. Sure? Okay. Yeah, sorry guys. Hopefully we're not boring you too much up here.
This will all be on SlideShare here shortly.
Yeah, so if we just quickly crack the hash. You're not really missing much there. It's just more the methodology that we took to.
So what do you get for the application? Is there a cost for the application? Can you download it for free?
Oh, Empire? Oh yeah, fully open source. Fully open source.
It's
right
on our adaptive threat GitHub.
Yep.
So
we're actually going to share that link as well, of course. So at this point, as we talked about, we're going to quickly go ahead and initiate that NS lookup for the DC, so we can actually bind to it. And this starts our basically user hunting functions and the normal network situational awareness stuff. I'm actually going to hand it over to Steve as he's going to go through some of the rest of the demo.
yeah, sure. I'm going to skip through this here real quick. So what we've done so far is we've gotten a spot on a box through macro OSX or OSX Office macro. Got on the machine, we escalated privileges with sudo, we copied the user's password with the clipboard monitor because of course they use some password safe, but you can get that all through the clipboard. Launched sudo spawn, got an elevated context, dumped the local administrator hash. Now we're looking for other systems on the network that we can get to and hopefully move laterally. So what we're going to do here is move to another OSX box with the SSH launcher command. That's this one. So this will actually spawn a remote agent with that local admin password we found on the OSX3 box. We get that back. You can see that we've got administrator access on that machine. We see that domain administrator is logged in, and we're going to keychain dump and there you see we have clear text passwords come back from keychain dump, and then we're going to attempt to mount the domain controller with SMB mount command that we have built in as well. And if we can mount C drive on the domain controller, that means we are finally DA. And there we go. So we've gone from phishing through a macro, local host enumeration, network enumeration, and onto domain administrative accounts all through Empire. Any questions? Yes? No, it's different, and this actually the keychain dump module uses a I think it's not really considered an exploit, but they patched it in El Capitan to where it would just let you get the keys out in clear text from memory. So Capitan has it patched. We have to do it offline and kind of brute force it. So, any other questions, comments? Hopefully we'll go hack all the OSX things. I'll throw this link to our adaptive threat, command and control. I don't want to give away any tips there. Like I said, it's open source. Feel free to hopefully contribute. We found that